Hey there, welcome to the second video of Math Foundations Pre-Calculus 10. Ha, got it right that time. Today we're going to talk about the greatest common factor. If you have not watched the first video and you do not know how to do prime factorization, just stop now, go back and watch the first one, because otherwise this isn't going to make any sense. Okay, so we're going to talk about factors first, and then we're going to talk about greatest common factor. And we're going to use prime factorization to do it. And it's really pretty easy. Not really fast, but pretty easy nonetheless. Okay, so first I wanted to define what a factor was. A factor is a number that divides evenly into the given number. Sorry, I need to learn how to read. A factor is a number that divides the given number evenly or exactly, leaving no remainder. So for example, 3 is a factor of 15 because when you go 15 divided by 3, you get 5. And it's a nice whole number, divided evenly, no remainder. 4, not so much, is not a factor of 15 because when you go 15 divided by 4, you get 3.75. Okay, decimally part, not a whole number. If you were wondering what the remainder was, this is the remainder. Right, it's the leftovers. Hold on, let's see if I can do this. In the old days, kids, we would do this. We would go 4 divides into 15. That goes 3 times. 3 times 4 is 12, which leaves me a remainder of 3. And sometimes, depending on what we were up to, we would just finish our answer just like that. Sorry about that. I'm recording at school, so sometimes I have stuff I need to do. Anyway, okay, getting back to our greatest common factor. The greatest common factor of 2, okay, so 2 numbers at least. In the previous video, when we were talking about prime factorization, we were doing 1 number at a time. Now we're going to do at least 2. And I know one of the examples has 3. And there's 2 definitions. This one is my new one. I like it. It's the product of all the factors common to both numbers. So we know what factors are. We know what common means. Common just means it's in both of them. So I'm kind of repeating myself. And product just means multiply. But I'm old. I've been at this for a long time. This is what I'm used to because that's what I was raised on. I was also raised on a rotary phone and a party line. So you might have to ask your grandma about what that means. I was taught it's the biggest number that can be divided evenly into both numbers, and that just sounds awkward now. This is so much prettier. Okay, so there's a couple of ways to do this, and I'm just going to show you the prime factorization because when in doubt, try it out, and it's easy. And it always, always, always gets you the biggest one. It always gets you the greatest common factor. Works like a charm. And I put a little question beside if it's faster. But the more you do these, the better you're going to get. So number 1, try out each number. Trying out is just prime factorization. So I'm put 12 over here. That's 3 and 4. 3 is prime. 2 and 2. 42. Now, I'm going to brag because I know my multiplication table. I'm going to use 6 times 7. And this is going to be 2 times 3 times 7. My heart right now, my heart wants to put these in order, but we don't have to. We're going to save some time. And actually, hold on. Like 5 different colors for $1.25. I can see in my first number, there's a 3. Oh, my blue's too dark. And there's another 3. So that's a common factor. Wait, there's more. There's also a 2 in this one and in this one. Okay, so We're talking about numbers that are in both sets. This, not a common factor because there's no 2 over here. I already paired that off and the 7 doesn't go anywhere. Often, I've done this, but really, it starts to look really nasty and messy. So the greatest common factor, remember the definition, was the product of all the factors common to both numbers. So there's a 3, and there's a 2, and that's 6. Greatest common factor is 6. So 6 is the biggest number that'll divide into both of them. Now, make sure to kind of check it. Gonna be lazy. Just to prove a point, 12 divided by 6. Yep, it worked. 42 divided by 6. Yep, worked. So if your greatest common factor, you go to divide it into your original numbers and it doesn't divide evenly, I'm sorry, you messed up. Okay, let's do another one. And I will tell you that on your exam, I'm going to say, show me how to do this, because I suspect there's some of you who might be good at your multiplication table and can stare at that and tell me what the greatest common factor is, but I want to see. All right, so pause the video and break down 36 and 48 and see how far you can get. Okay. I hope you pause the video. 36, 6 times 6, which is 2 times 3 times 2 times 3. Okay, 48. That's 8 times 6. That's 4 times 2, 2 times 3, and 2 times 2 times 2, 2 times 3. There we go. It doesn't have to be, but this is just bugging me. So I'm going to go 2 times 2 times 3 times 3. I just put it in order. So now let's see what's common. Oh, hey, maybe this is easier. I've got 2 2s and I've got 2 2s. I think I like this. Yellow. And oh, I've only got 1 3 and 1 3. So there's my greatest common factor. Greatest common factor is 2 times 2 times 3. So once you're done, I wouldn't only look at 1 to get my greatest common factor out. Okay. And that is going to be 2 times 2 is 4, times 3 is 12. And there we go. And because I bought hamburger buns, 36 divided by 3 is 12. Or sorry, 36 divided by 12. You know what I mean. 48 divided by 12 is 4. It works out evenly. Yeah. All right. I don't think I need to make a second video on this because I know there's another page of this. What y'all, there comes my southern drawl. I got told that I sound like a southern lady some days. Sorry, for those of you that don't know me well, sorry. Pause the video. Pause the video, do the work yourself, and then turn the video back on, or just look at the answer key because maybe you don't need to see me doing this. The worst thing to do is to sit there while you're scrolling on your phone and say, yeah, I'm watching a math video. No, you're not. You're paying attention to what's on your phone. Hey, I'm just telling it like it is, my friends. So put everything away. Hopefully the children are, in bed. You're doing this. The cat's busy doing cat stuff somewhere else and not bugging you. But seriously, turn it off. Try it yourself, because otherwise you're going to come to the exam and possibly be stressed out, but you're going to have no idea because I'm not talking in the video. So I think I'm hopefully convinced you to turn it off. All right, let's do this. Not that it matters, but it's like 3:45 and I'm done at 4, so I want to get done. All right, so 160. I remember, whoopsies, from my prime factorization that each of these are going to be divisible by 10 because they end in a 0. So this is 10 times 10, 2 times 5, and 2 times 5. I also could have used 4 times 25. It doesn't matter. 60 is 6 times 10. And this is going to be 2 times 3 and 2 times 5. You know what? I like this. I like putting them in order. 2 times 2 times 3. It looks prettier for me. So out come the highlighters. I'm going to make it very colorful. So 2 here and a 2 there. That's one common. And there's a 2 and there's a 2. Yep. And blue. There's a 5 here and a 5 there. And I'm done with what's common because there's a 5 and a 3 and they're not matching. So 2, 2. Oh, whoops, made out of mention that in math. A dot like that also represents multiplication instead of the time sign. So 2 times 2 is 4 times 5, and that's 20. And that's kind of funny because I was actually thinking as I said it, I started this question, oh, well, the greatest common factor must be 10. No. 10 does divide evenly into both of these. In fact, it goes 6 times and it goes 10 times. But the biggest number that'll divide evenly is 20. 60 divided by 20 is 3. 100 divided by 20 is 5. So this works all the time. It's a beautiful thing. All right, 98 and 56. 2 times 49. 2. And I memorized that's 7 times 7. 56. I don't know what is about that number. 56 bothers me. I can never remember what the factors are. So I'm going to go divide by 2. Okay, 2 times 28. 2. I know this is 7 times 4. 2, 7, 2. Okay. So 2, 7, 7. Again, that step we don't need. I just like it because it looks pretty. 2 times 2 times 2. Okay. It looks pretty. It's kind of a silly statement, but it helps me organize my work. I've got a 2 here and a 2 there. Done. I've got a 7 here and a 7 there. And then I'm pretty much done. Because remember, the common factor has to be 1 in each. I don't care that there's a pair of 2s there. That has nothing to do with this lesson. So carrying on. My greatest common factor is equal to 2 times 7. 14. Ta-da! Are you liking this? This is pretty cool. I think it's pretty cool. Maybe not. Maybe I'm a nerd. Do it again. Feel free if you're feeling more comfortable and you haven't done it all. Stop the video. Practice on your own. Okay. Put this down. There we go. 88 and 66. Okay. Well, I know any double number is a factor of 11. So it's 11 times 8. 2 times 4. 11 and 2 and 2 and 2. And 66 is 11 times 6. So the 11 comes down. And this is 2 times 3. Put it in order. Dollar store. Package 5, buck 25. Super investment. Just hold on. All right, sorry about that. Again, I'm doing this at work. So where are we? Oh, yes, we're looking. We got 2s. So there's no more 2s. So these guys don't matter. There's no twos over there, but there is an 11. So my greatest common factor is 2 times 11 is 22. And it's funny because again, when I looked at this, I thought, oh, greatest common factor is 11. Nope, I was wrong. It's 22. 22 will divide equally into both of those. So trust your prime factorization. Don't necessarily trust your brain. All right, last one. What? Yes. You can do the greatest common factor of 3 numbers. And you know what? It's exactly the same at the start. So 56. And I now know, because we did it a little while ago, it's actually 7 times 8. So 7, 4 and 2. 7 comes down. 2, 2, 2. Done. 42. 6 times 7. 2 times 3 times 7. And yes, we're going to do 12. 12. 4 times 3. Almost had a brain fart there. 2 times 2 times 3. All right, I'm just going to rewrite this one. 2, 2, 2, 7. These guys are already in order. So now when I look for the common factor, it has to be in this set, and this set. That's why there's 3 numbers. So there's a 2 and a 2 and a 2. Now, there's a 2 here and there's a 2 here, but there is not a 2 there. So we're done. That doesn't work. Neither does this 2. And same thing with the 7. There's a 7 here and a 7 there, but no 7 over there. So the greatest common factor of these 3 numbers is sadly 2. Done. I want to show you one question. I'll make it really simple. Let's do 4 and 15. So I want greatest common factor of 4. Whoops. Let me move my camera for you. Of 4 and 15. 2 and 2. 3 and 5. So what's common? Almost nothing. When there is nothing in common, the greatest common factor you actually put as 1. It's the only time that you really care that 1 is a factor if they have nothing. So when no common factors in your trees. There we go. Because 1 is a factor of every number, but number 1 is not a prime number. And all of this stuff, it's all about prime factorization. That's kind of our, well, I got nothing else, so we'll do that. Anyway, thanks for joining me. This was swell fun, and I'm sorry about all the interruptions, and I hope you have a lovely day. Bye.